Hey everybody, welcome back to Electronics. We're coming to you again from the Miami Lakes Learning Center, and today we want to talk about the FMI-5 code. So with the FMI-5 code, current below normal, to kind of understand where that's coming from, let's take a quick look back at Ohm's law. So Ohm's law is our voltage is equal to our current multiplied by our resistance. So in this case, current below normal. As long as our voltage stays the same, if the current drops below, the resistance then has to go up. Current and resistance are inverse of each other. So in this case, current below normal means my resistance goes really, really high, all right? So if we think about a circuit with very, very high resistance in it, that would be more of an open circuit condition. So if I have a completed circuit, I've got a completed wire right here, right? If I make an open circuit in my wire, that air gap right there, that's a lot of resistance. So in this case here, current below normal, if current is low, resistance is very, very high. That is an open circuit condition. It's the most resistance that we can have, which results in a very, very low current flow, all right? So current below normal, we said that is most likely going to be an open circuit condition. So here we go. Right here, I've got a completed circuit with my hands here, right? And so right now, that's a completed circuit. We've got good flow, okay? Now, if I break that circuit and my circuit comes down here, now do you see my broken circuit just become a -5 code? I no longer have a completed circuit. So I like to come up with kind of interesting ways of remembering things. -5, current below normal. If you think about that's a completed circuit. When we break the circuit, make an open, a -5, that's current below normal. All right, so we're back out here in the lab now. Let's talk a little bit about troubleshooting this -5 FMI code. We're out here on our 3500E Tier 4 final well service engine. It's also got this dynamic gas blending feature on it, the DGB engine also, that we've got down here in the Miami Lakes Learning Center. So let's say that we've got an active -5 code on one of our output circuits. There are a couple of different options that we have here. If we happen to have a diagnostic test within CAD-ET, it will show us whether or not we have an open circuit or a short circuit condition on one of those outputs. And we happen to have some of those here. So on our engine here, within diagnostics and then diagnostic tests, for the engine ECM itself, we have an injector solenoid test. It's probably something that you're familiar with if you worked on CAD engines very much. We've had injector solenoid tests around for a really long time. We also have a gaseous fuel valve solenoid test. So on this engine, it's got solenoid operated gas admission valves. Very similar, or somewhat similar to our injector solenoids. It's a solenoid controlled by the gas ECM. So we can go in and either our injector solenoids or on this engine, our gas solenoids, we can go in and run a test here. So if I go into my gaseous fuel valve solenoid test, very similar to what you might be used to seeing on the injector solenoid test. And if we run this test here, we're gonna see it's going to click all of our gas solenoids. So let's give that a go. All right, so I've got 1 through 12 gas solenoid here. We can hear it clicking the gas solenoids as we go here, and it's showing right now, at least the ones we've got so far, they're all okay. So we're gonna let this run through here. All right, so there we go. It ran through all 12 of our gas valves and says that everything's okay here. So that's a test that we can do here. Now, we said we want to look at this -5 code as far as troubleshooting is concerned. This test is going to be very useful to us. So let's go ahead and set up a scenario here where we have a -5 code active on the solenoid and how we're going to use this test to help us troubleshoot. So let's run through a troubleshooting scenario here. Let's say on my solenoid operated gas admission valve, number 10 here, I've got that -5 current below normal code. On that solenoid, it's this one right here. So if I had a -5 code, we talked about how that's most likely an open circuit condition. So I can go out here to my solenoid disconnect it. Now, I just made an open circuit condition, so really I didn't do anything at this point in time. But if I come out here now and try to make the opposite condition of that, which would be a short circuit, I'm going to do that right here between my two wires. All right, now I started out with a -5 code, which we said was most likely an open circuit condition. Now I've made a short circuit condition. Now we can go through and run that solenoid test again and see if the ECM should see that we've made this short circuit here. This is going to tell me if I've made a short circuit here and now the test tells me, hey, you got a short circuit on the end of your harness. From this point down here to my gas ECM that controls that solenoid would tell me that from here back, everything is behaving like it should. That tells me that my problem is going to be either within my connector here or my solenoid itself has got an open circuit. All right, so we said in our scenario we've got a -5 code, most likely an open circuit on our gas valve solenoid number 10. So within my test here, I can go in, since that's the only one I want to test out, I can go in here, I can say cut out all. And then if I only want to test number 10, I can do that and go ahead and set it to powered, okay? Now, I made my short circuit up at my harness. So let's go ahead and test the circuit now. So I hit start. It's going to test the circuit. And there we go. It tells me not okay, short circuit. That's the fault that I put up at the harness. So I made a short. The test is telling me I have a short. That tells me from the end of the harness all the way back to my gas ECM, I saw a change. So now that tells me I am going to go the other direction. I'm either in my connector and my wiring to the solenoid or the solenoid itself. That's where my failure is going to be. Now, if I were to have made that short circuit, I ran this test and it still told me not okay, open, well then that tells me that the harness from my solenoid and the solenoid itself is probably good. And in that case, where I made my short up at the end of the harness back to my gas ECM, I still have an open circuit. So in that case, I'm going to do the same thing that I just did out at my harness. I'm going to make a short circuit condition, only now I'm going to do it down at the ECM. Run the test again. If it tells me, hey, yeah, I see the short circuit at the ECM, then that tells me the ECM is good, and the only thing left in the equation is my wiring harness from the ECM up to the solenoid. If I make the short circuit at the ECM, run the test, and it still says not okay, open, well then that would give me an indication that the open circuit is going to be inside the ECM. But we can very easily and quickly use this test, whichever code we're dealing with, -5 in this case, an open circuit condition, make the opposite condition, run the test, and the results of that are going to tell you which direction in the circuit we're going to go. It's pretty simple logic. If we have an open, make a short, run the test, and find out what that's going to tell you from there. All right, so we looked at troubleshooting a -5 code utilizing our gaseous fuel valve solenoid test. And within there also, you know, we've got our injector solenoid test here. We would utilize that in a very similar way than what we just looked at for our injector solenoids. But what about some of our other outputs that have a -5 code? We said -5s and -6s we're going to find on our output circuits. So some of the other outputs that we have available here, we can override those also. So within diagnostics and then diagnostic tests, I've got override parameters right here. So if I open this up, it's going to bring up a lot of my other output circuits that I have available to me. So in this case here, I've got things like my air shutoff valve, my EGR valve number 1 and number 2 that I can command, my electric fuel transfer pump relay, things like my fuel pump control relay, my starting system relay. So I can utilize these because a lot of times with -5 and -6 codes, the ECM may not recognize the change. So if we have an open circuit, we make a short, we want to see that code change. The ECM may not recognize that change unless the output circuit is actually activated. So in those cases here, we're going to have to go out to our output circuit. If we're dealing with an open circuit, we want to make a short. If we're dealing with a short circuit, we want to make an open. And then we may need to come into override parameters to utilize this and have the ECM actually turn on or activate that output before it sees that change in state from an open to a short or from a short to an open. So in this case here, let's say my air shutoff override, I can double click on this, go in here, change this from off to on. Am I sure I want to do this? Yes, I am. So we click yes. You might have heard the click there. So the ECM actually turned on or activated, sent the signal out to my air shutoff solenoid. So if I were troubleshooting this, again, if I had a -5, I'd have made a short circuit in that harness, ran this test, and then see for my code to change, and vice versa. If I'm dealing with the -6 code, then that's a short circuit, I would make an open circuit, activate the output this way, and see if my code flips. So just keep in mind, with output circuits, the ECM may not see that change in state until we actually turn it on. We could put the engine in a certain state in order for the ECM to activate those outputs, or we can go in here with key on engine off and actually override those parameters and utilize this for troubleshooting. All right, everybody, thanks for joining us for this episode of Electronics. It's been great coming back to you from the Miami Lakes Learning Center down here. If you got any ideas for other topics that you'd like to see us cover on this channel, be sure to leave some comments down below. As always, if you want to come back down for the week-long electronics troubleshooting course, we do offer that. So go down to DPC and search for this course number right here. That's our electronics troubleshooting class. Once you've attended that one, you can come back for this course right here. That's our Electronics Troubleshooting 2 class, where we get into troubleshooting data links, we get into using scope meters, and a lot of other really fun stuff. So be sure to take advantage of those classes and all the other classes that we offer down here at the Miami Lakes Training Center. We've got a ton of different assets across a lot of different applications for you to take advantage of, so be sure to do so. And hey, since this is the electronics channel, always make sure every time that you're nice to those electrons, they're also really nice to you, so be nice to them.